Alright, welcome back. Let us look at some actuators and understand some basic characteristics of basic types of actuators and what are the selection criteria associated with these actuators, and of course we will follow up with a small demo, okay, that will give you some idea of how to choose an actuator and for different applications. So what is an actuator if you ask? Actually this is a document which we found on the internet and you can download it yourself. Essentially it is a muscle behind all mechatronic systems, okay, and basically it accepts a control command and it produces a change in the physical system, okay, that is the key thing. It generates a certain force, it can be in terms of motion, it can be a generating force, it can be motion, it can be heat, it can be flow, etc., right. If you actuate a heater, then it will produce heat. If you actuate a valve, it may actually bring in certain flow, right, it may actuate a flow. If you connect it to a, let us say, a robotic arm, it may generate a certain force and you have a force, the robotic arm itself will generate a certain force, right, and so on. So these are all actuators essentially, okay. Now you can classify actuators of different types. You can have actuators which can be under basically under binary type of actuator, on off kind of actuators, or you can be talking of continuous based actuators which are based on stable state outputs, okay. A relay for instance has two stable states, is a good example of a binary actuator, okay. Even a solenoid valve for that matter can be regarded as a binary kind of actuator, on, solenoid valve is on, solenoid valve is off. You can also have a valve which is sort of continuously opening, that means you control a solenoid valve, control the power to it in such a manner that you open it, let us say half, you open it 1/4 and so on. So such valves are also existing, such solenoids also may be available, but by and large solenoids will give you on off, okay. You can also have different types, variants of the solenoid valve which essentially are different types of valves where you can have continuous change, okay, that is also possible. As I said, you want to open only a small orifice so that a small amount of flow goes, then you open it little bit and so on. So that is also another possibility. Similarly stepper motor, again he goes back to another example of good example of continuous actuator. What happens in a step motor is, if you take a step motor, typically step motors you will get as 200 step motors, okay. You will have 200 steps which the rotor can take. If you look at my hand motion, this is like a motor, this is like a shaft, the shaft goes cut, it goes like this, and each time it moves by 1.8 degrees, that is why you get 200 steps when it completes one full rotation, okay. Now supposing for every pulse I feed it moves by 1.8 degrees, okay. Now if I start increasing the frequency of the pulse, then you will see that the shaft is rotating continuously, which means it is continuous actuation. Each pulse will give it an which will move it by 1.8, and because the frequency of the pulse is high it moves continuously. So what the eye sees is a continuous motion, but actually the actuation is in a step way, right, for each pulse it is moving in a step. Therefore that can be regarded as something which is like a continuous actuator, okay. But when you use it for position control, that means you want it to move by, let us say 10 steps, okay, that means you want to move it by 18 degrees. I am assuming that it is a 1.8 degree step motor. You give something, you give it a command, it will go and settle down at the end of 10 steps, which means it would have moved by 18 degrees. Then you can think about it like a binary motion, that is in every 18 degrees it goes and halts itself there, right. So the notion of continuous and binary depends also a little bit on what you want to do with that actuator, like solenoid as I mentioned. So careful about the interpretation of continuous and binary actuators, okay. Now when you talk about actuators, you can be talking about electrical actuators, you can be talking about electromechanical actuators, you can be talking about different types, okay. So let us see a nice table which talks about these actuators. So, diodes, thyristors, bipolar transistors, triacs, diacs, power MOSFET, solid state relay, these are all electrical type of actuators, but they are basically devices which are electronic devices, right. So, they are basically electrical electronic type of devices. They have extremely good frequency response, very high frequency response, and sometimes they will be very low power consumption. Now DC motor is a classic example of being an electromechanical kind of actuator. Then you can have wound field, or you can have permanent magnet kind of DC motors, or wound field motors, where the way you excite the windings makes the huge difference, okay. And there are advantages and disadvantages of each one of them. In permanent magnet you have conventional permanent magnet, you have moving coil and so on. So again he talks about different types of motors. You can also have brushless motors which give you extremely fast response, highly efficient, over 75%, very long life because there are no brushes here, it is brushless DC motor, okay, and so on. So do have a look at it, these are all also actuators. A DC motor is a very good actuator. AC motor, AC motor we can think about synchronous motor and also induction motors. Several industrial plants use induction motors, right. Most commonly used motor in industry, simple, rugged and very inexpensive, starting with floor mills where we grind our grain, to extremely important like toy making, or any kind of factory you can think of, they will definitely have an induction motor for sure. So it is the most commonly used motor for any industry, simple, rugged, inexpensive, easy to service, okay. Then you have AC synchronous motor, rotor rotates at synchronous speed, very high efficiency again, and a wide range of speeds and loads, but the only thing is it needs some additional system to start. And you also have what are known as universal motors, they can operate on DC and AC, very high horsepower, relatively short operating life and so on. Then you have stepper motors, several of the printers, old printers, dot matrix printers that you know, or floppy disk drives which were being used in computer hardware. I am talking of 2 decades back, okay. Floppy disk drives or computer dot matrix printers, they all had step motor drives, and therefore step motors are quite common. In fact nowadays if you look at 3D printers, 3D printers will have step motors inside them for very precise movement. Good thing about step motors is you can drive them in open loop, right. You just give a pulse, it will move by whatever degree it is designed for. Typically it is 1.8, you can also do half stepping, which means it will move by 0.9 degrees. So all these possibilities are there. You can provide, it will give you very good positioning without feedback. That is the reason why I said you can do open loop operation of this. And also there are other types of motors which is also called a variable reluctance motor, okay. Variable reluctance in big sizes are very popular, they have extremely low maintenance, there are no magnets in a variable reluctance motor, so that is a good thing. So once dependence on magnets can be done away if you design good variable reluctance motors, okay. Then you come to solenoids. Solenoids are also electromagnetic by nature, unlike the other ones which are electromechanical by nature, and you will have electromagnets, relays, all of them come under one class of electromagnetic. Large force, short duration, on off something that you can be guaranteed. Then we will do a demonstration of a solenoid type of device which comes under the electromagnetic category. Then you can also have hydraulic and pneumatic, you have hydraulic motor, then you have air motor, then you have valves which are also directional control valves, pressure control valves and so on, they are all coming under the hydraulic and pneumatic kind of actuators. You can also have smart material actuators, a really strong upcoming area, piezoelectric and electrorestrictive kind of actuators. These are all for high frequency with small motion, high voltage and low excitation and high resolution kind of actuators. So again shape memory alloy is something that is very popular under this broad category of smart material based actuators. Micro motors, micro valves, micro pumps, all of them come under micro and nano actuators. There are mostly PCB mounted kind of micro motors, okay, very small motors, okay, suitable for micro mechanical systems, and they can be available using silicon processing technology, and it can be like a micro motor on a chip, okay. So that is typical of what we talk about in micro motors and micro valves, and they may have medical applications, okay, several of them have medical applications. Alright. So that is broadly what you have in terms of actuators that you will find, and I hope if you read this document you will get to know a lot more. The point is, in terms of the selection of the different type of actuators, there is a requirement to know what are those technical parameters with which you should select a particular type of actuator. So I have these many points that you may want to look up. I have it right on the table here. You have continuous power output, range of motion, if it is linear rotary kind of motion, what is the range, how many mm will it move, how many centimeters will it move, and so on. What is the maximum force if it is continuous power output or torque. Torque is usually measured in Newton meter. What is the kind of torque it provides. Resolution, what is the minimum increment in force or torque that you can see. What is the linearity, what is the accuracy of the system. Peak force or peak torque, heat dissipation in terms of maximum wattage of heat dissipation, speed characteristics, speed torque characteristics, right. When you plot any motor, you are interested in finding out at what speed you get the maximum amount of torque. So speed torque characteristics of the motor you may want to look at from the specifications of the manufacturer, okay, and you may want to choose based on the speed you are likely to operate on for your application, okay. So all those matching will have to be done based on, very important, I keep stressing it 100 times in this course, data sheet will tell you what is the motor to choose if you are looking at the right speed, okay, and what is the torque requirement for that particular speed. Then there is frequency response, and then there is also the power requirement which is an important thing, right. So these are broadly what you want to look up, the type of actuators which are out there and the selection criteria that you may have to apply. Basic principle of the actuators is mentioned in this document, which you can easily download. I really appreciate this document because it has covered the actuators in some detail, and it is good for you to read up yourself. In fact, it also has something on sensors. So if you go up and look up this document, sensors and actuators, you can easily download this chapter. It is chapter 16 on introduction and actuators. Yeah, so this is the paper, introduction to sensors and actuators, written by 3 people here, 3 researchers, and they have done a good job of it, okay. Sensors also you can spend, because sensing is an important thing. Please do look up the sensors also, and then of course actuators you can directly use from whatever we discussed here. You can go through this file in great detail. Okay, great. Strain gauges are important from a sensors perspective. Do read up strain gauges, the corresponding circuits for strain gauges, okay. Then there is acceleration sensor, flow sensor, temperature sensor, proximity, light, smart material sensors, micro and nano sensors, like actuators also micro and nano sensors. Then associated selection criteria, right. So you see range, resolution, accuracy, precision, sensitivity, 0 offset, linearity, 0 drift, response time, bandwidth, resonance, operating temperature, dead band, signal to noise ratio, all important parameters for choosing a sensor of interest, and what kind of signal processing, the kind of calibration that is required for these sensors. Particularly if you look at air quality, you must look up the sensor manufacturer for the calibration curves, right. So, all of that will have to come again from the data sheet, very important. Then of course, what we discussed now is about the actuators. Alright, now let us move on to an actuator of interest to us, and I will point you to the actuator that we would like to show you, and that comes from this company, it is called Genetics. This is a solenoid valve, and the solenoid valve of interest that we would like to demonstrate is this model E12612W, and again as we just discussed, it is important to know the technical specifications of this valve, solenoid valve. So, you have to go there and look up the specifications in great detail. Okay. So, there you are, this is the valve of interest, category number is J013-2. You can see features are wide range of coil voltages, continuous duty cycle, and low temperature of operation, noiseless performance, coil can be rotated by 360. Why should you see a picture like this when I have this in my hand? So, let us look at my hand now. Okay. See, this is the same valve that we have here, same thing that you have saw in the picture. This is operating at 24 volts, and these are the two wires. You apply a voltage, this is a binary solenoid valve, it will open, you give a command it will open, you give another command it will close, okay. And this is mainly used for air applications, okay. It is air that it is trying to allow or disallow or block, okay. So, that is essentially the function of this actuator. There is a nice specification here, it says this is DC 8 watt solenoid valve, it consumes 8 watts of power, and its duty cycle of operation is 100%. That means it is giving you either on or off, that is what it is trying to tell you. There is nothing like you can keep it in the middle position. So, essentially that is its operation. So, you look up the technical specification, maximum temperature, remember we did talk about the selection criteria and the technical specifications. Ambient temperature is mentioned here, it is 60 degrees, medium is filtered air, compressed air, and orifice is shown, operating pressure is shown, and 0 to 10 bar is the maximum it can control, and flow rate is 140 liters per minute, and coil width is mentioned, the electrical parts are also mentioned, and it is meant for outdoor applications, that is why it is IP65 protection, and class of insulation is mentioned, and so on. So, let us now shift to a demonstration, and I will explain the demonstration setup for you. What you see is a power supply here, and this power supply will essentially you will see the current consumption change, okay, and I let you locate the change in the current consumption. What you have here is a source which generates a certain amount of pressure, okay, and it tries to fill up this cylinder. Let me take this. So, this is the source which is generating some amount of air, and this air with a certain pressure is filled up in this cylinder, small little cylinder, and this is measured by this sensor, okay. This sensor will measure the pressure inside and switch this off. Moment this pressure is reached, this pressure is sufficient to open this valve. This is the solenoid valve of interest, okay. It is a very basic demo where sensing and actuation, both of them are together. You will hear a peculiar sound whenever the actuator goes on, and whenever the actuator goes on you should also be able to find out what is the current consumption, okay. I must tell you the operating voltage is 24 volts. So, what should be the current consumption that you expect, so that the specification of the valve is 8 watts, roughly 8 watts. So, you should be able to see that about roughly 8 watts of power is actually consumed every time there is a solenoid operation, alright. So, this is the demo setup. So let us see what actually happens. Let us start it and then let us see what happens. See now, you hear that sound, this is coming from the solenoid. Every time the solenoid is on, look at the current consumption on the screen, okay. You get roughly 0.32 amps, you can see that it's 0.33, 0.32, 0.33, it may even go up to 0.37 and sometimes it may be fluctuating for you. You can see now it is 0, it is off, solenoid is off, okay. Now you can again see it will go on, there you are, there you are, okay. The current consumption is not measured, cannot be measured directly like this, but if you keep it on you will see its steady state current, okay. Let us keep it on in steady state, there you are, see 0.38. So now you can calculate what its wattage is, and that is about it, this demo. You saw that there was a nice source which generated certain air with a certain pressure, it was filling up this tank, small little tank cylinder, and that the pressure was being measured by this pressure sensor, and moment that pressure reached this source was turning off, at the same instant in time this actuator turned on. So that is the basic demo of sensing and actuation, right. This is something which is familiar for you, the one in my hand. This is used for water, it is also a solenoid valve, but it is used for water applications. What I showed you there was for air, this is for water, inlet and outlet, and this is what is typically used in all the water filters, okay. Solenoid valve operating at 24 volts. Remember, solenoid valves, industrial applications, they are mostly 24 volts, be very clear about it, okay. That is one, this is one type. Then this is a pump, this is a pump, okay. This is used to measure, this is used to maintain a certain flow of air. Supposing you are making a air quality measurement and your air quality sensors have to be maintained, have to be measured with a fixed air quality at a fixed flow, and that time you use a pump like this, and this is also an actuator, okay. Second one. Then you have a fan, a simple fan, this is also an actuator, right. So you have different type of actuators which you can put up in an IoT system and start looking up, start designing your experiments around these sensors and actuators. Thank you very much.